Okay, so in this video we're going to be going over the convolution and some of its properties. I've listed them here. Essentially, this symbol, the star with the F and G to the right of it, means it's a convolution. And a convolution is equal to an integral from 0 to t of f, so the first term, t minus v, times g of v dv. We also have the Laplace transform of a convolution is equal to the Laplace transform of f times the Laplace transform of g. Finally, we have the inverse Laplace transform, which is just the same property, just written backwards. So let's do some problems involving these properties. So for this, we have 14 over s plus 2, s minus 5. And basically, we can rewrite this as 14 times 1 over s plus 2 times 1 over s minus 5. And when we rewrite this, we realize we have a Laplace transform multiplied by a Laplace transform. Oh, and I should write the goal of this question is to find the inverse Laplace transform of this function. So essentially what we have here is two Laplace transforms multiplied by each other, where this is e to the negative 2 and this is e to the 5t. Or negative 2t. But anyways, we can write this as 14 times the convolution, because of the inverse Laplace transform property, e to the 2t convoluted with e to the that's going to be a negative 2t, e to the 5t, and this will be a positive 5t. Okay, so we can simplify this a little bit further here. We can say the integral from 0 to t times f of t minus v. Well, f of t minus v is this term minus v. So we have e to the 2 t minus v. Or remember, that's a negative 2. I keep forgetting that for some reason. Times g of v, which is just e to the 5v dv. Okay, so now what we're going to do is take the integral of this with respect to v. Well, we can take the e to the negative 2t out because we can treat it as a constant. That's partial integration from Calc 3. And we're left with the integral of e to the 7v, because we have e to the positive 2v times e to the 5v, which is just e to the 7v. And the integral of that is equal to e to the negative 2t. Oh, don't forget this 14 out here either. So let's write that 14 e to the negative 2t times 1/7 e to the 7t minus 1/7, because e to the t to the 0 is 1 times 1/7 because of the integral. Okay, now distributing this, you're going to be left with 2 e to the 5t minus 2 e to the negative 2t. Okay, and this will be the inverse Laplace transform of this function. And what we did, remember, is we recognized there was two Laplace transforms being multiplied by each other. So we could say this equals the convolution. The convolution is equal to this integral. So by solving this integral, we find the inverse Laplace transform. Okay, let's do one where we're going the other direction. This question is asking for the Laplace transform of this function. Okay, so what I like to do is I'm going to treat this as f. So f is equal to t minus v. So f is just f of t, sort of. So we're going to treat this as sine t. This term right here. Convoluted with, well, g to the v is e to the v, so we just say that's e to the t. Okay, so that's the convolution of this. But how do we find the Laplace transform? Well, we're going to use this property, where this property says the Laplace transform of f times the Laplace transform of g is the Laplace transform of this. So, not too bad. The Laplace transform of sine is just 1 over s squared, s squared plus 1 times e to the t, well, that's 1 over s minus 1. And not that bad. That is the Laplace transform of this integral. And again, all we did was realize this is a convolution integral, so we converted it to its convolution, and then we used this formula to find the Laplace transform. Not too bad.